Hey everyone, this is Mr. Sal. This is just a quick lesson on the difference of squares and squares of binomials. Very special cases and their rules that you would have to memorize, but all these can be done by factoring by grouping as well. So thanks for watching. Don't forget to like, comment, and subscribe. We're really just looking at perfect square stuff. Perfect squares are numbers where we take a whole value and multiply it by itself. So we're looking specifically at, for example, 1 times 1 is 1. No surprises, hopefully. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. We got a bunch more. I don't know, 13 squares, pretty good. And also, some of you guys notice a pattern in there, because you're kind of nerdy like that, like me, right? 1, 4, 9, 6, 5, 6, 9, 4, 1, 0. That pattern repeats, which is kind of nifty if you're nerdy like me, okay? But we are looking at these perfect squares. We're going to see these ones, I think, more often than any others, because anything above that is uncommon perfect squares, which we rarely deal with anyways. But we want to look for these numbers in our trinomials from now on, even the binomials, okay? Because if they happen, then we can move on to the next step to see if the middle term is the sum of the two, or two of those values. Whatever. We'll look at some examples here, okay? Now, when it talks about the remaining term there, it's talking about the middle term, which is why we're gonna, in this next slide, we'll see what that kind of means right there. So like this, if our first term is some kind of perfect square, now it doesn't have to have one factor in it or one multiple. For example, it could have been like 25x squared, and then b, maybe it would be some squared value as well, like 16y squared, okay? So if this is the case, just looking at these two terms, we should have an a value and a b value. And if this was the case, then a would be 25 would be 5, and the x squared would be the x if we squared both of them. So the a value in this is 5x. Now for the 16y, 16, you can square root it if you want, 4, and then y squared would be y if we had squared 4y, which would then be the b value. Now for this to work, the middle term has to be 2 a's and b's. So, I mean, what would that give us, right? 2 and then times a, which was 5x. We're making up our own problem here, by the way. And then the b is 4y. Well, 2 times 5 times 4 is 40. So plus 40. And then we also had the xy, right? So if this was the case, if this is what we had, then it breaks up immediately into this perfect square binomial, 5x plus 4y, and that quantity squared. This is pretty much true always for all of our perfect square binomials, trinomials. Even if they look like binomials, if I remember right, we're going to be changing these into trinomials anyway. So this one looks like it's taking on that form, a squared minus, alright. So on this one, since it's got subtraction between the first and second terms, it's actually a squared minus 2ab plus b squared. We just have to identify what a and b are. What this results in is binomial a minus b squared. Again, it's just a matter of identifying what a and b are. Now, again, if you end up hating this now and then at the end of the section, just do it by grouping, okay? It's not a problem. It would still work. But since that's what they want us to do, that's what we'll do, okay? So 25, we just saw it, right? That ends up being 5x squared. And then 16y squared ends up being 4y squared. And then the negative 40 xy, is that negative 2ab? Well, let's find out. So that would be negative 2 times a, 5x, times b, 4y, and then you'd have to add that stuff in. And yeah, that if we combined all that together, then we would get 40, well, negative 40 xy. So yeah, it holds for the rule, which means we're just looking at this a minus b squared stuff. And I'm going to replace the a with the 5x. And also the b with the 4y. Done. So again, it's helpful if we can just look and see some of the perfect squares. 121 and 25, 25 is more common, but 121 is pretty good. So right away we can see that this would be 5w squared, because 25 is a perfect square, so is w squared for that matter. And then 121 is really 11 squared. So we should just check to make sure that 2 times a times b is 110w. So what would that be? That would be plus 2 times a, 5w, times b, which is 11. And then we would add that stuff as well. Well, 2 times 5 times 11 is 110. And then we still have that w, so that does check off. Yeah, so we do have that form, which means that we're going to get a perfect square binomial, a plus b squared. And so in that formula, with the a plus b, a is 5w, and b is 11. Done. This one's nice, just because it's different. But if we look at this one, we see that 12 is not a perfect square, and neither is 3. However, after that, then we should be looking to factor out some kind of greatest common factor, like we should have in the first place for all of these, okay? So, 12, 12, and 3, right, 12 splits up into 3 and 4, same with this one, 3 and 4. 3 is just 3 and 1. So I can factor out a 3 from each of these. And then, well, what am I left with? 4. Oh, I'm sorry. I failed to notice the x's in each of the terms as well. So it appears that I can factor out not just the 3, but the x's as well. So I really have 4y squared minus 4y plus 1. Well, now when I look at the two ends there, 4 is a perfect square, and 1 also is a perfect square. This ends up being 2y squared, and then 1 breaks down, I use a different color, into 1 squared. So again, we should just check that middle term to make sure that it's 2 of each of those. Now this is minus, right? So we got 2 minus 2 times a, 2y, times b, which is 1. Yeah, we got the 3x out in front. So I haven't forgotten about them yet. Well, negative 2 times 2y times 1 does equal that negative 4y, which means that immediately we should be able to split these up. Not that I need that there. And this one's going to be a minus from this first sign between the first two terms. And a was 2y, while b was 1. And that is going to be squared. But don't forget the 3x there in the front. So I still got my 3x. And I'm done. Alright, so let's say that we were going to factor by grouping because we couldn't memorize the rule. And that's okay. We still need to factor out the 3. The 3x. Dang it. Now I've still got 4y squared minus 4y plus 1. And I'll multiply the a and c values. 4 times 1, which is 4. And I need 2 factors of 4 to add up to negative 4. I'm looking at negative 2 and negative 2. So I'm going to break up negative 4y into negative 2y minus 2y Of course, we got the plus 1 and the 4y squared with the 3x there. And then factoring by grouping. And then negative 2y plus 1, I'm going to factor out a negative 1 to make that positive 2y minus 1. Of course, we got the 3x there in the front. I've got 3x. Now I can factor my 2y minus 1 out of those. And I'm just left with my 2y minus 1. This is the same exact answer we got, it's just not completely simplified, which is what the homework wants you to do. So how many 2y minus 1s do we have? 2 of them. So I got 3x times 2y minus 1 squared, done. Difference of squares. If we see a squared minus b squared equals, then it will give us two binomials, a plus b and a minus b, which is pretty convenient. Could we do this by grouping? Yes, we could, but it's a little weird. And I think I'm going to show it to you, all right? Just not in this first example. Oh, that's nice. So remember, difference of two squares, right, would be a minus b, and then a plus b. If you switch these around, it doesn't matter. I think I had them switched on that last one. Whatever. Let's just identify what a is. So this one would be y squared, and then 121 would be 11 squared. Of course, we got subtraction between. So that identifies what a and b are. A is y, and then b, I'll change the color there, is 11. Done. That's it. And we feel pretty good about that, but there is another way. Yeah, we do need to be careful with these, because if it said simplify, then we would not be done. I'm sorry, we would have been done to start with. Yeah. This one, we kind of look at and we think, what the heck, right? There's no perfect squares, at least in the numbers, which is a little cumbersome. But we can split up 12 into 3 and 4, and 75 actually splits up into 3 and 25. So the reason why we do that is because 3 is the greatest common factor that I can factor out from this expression. So that leaves me with my 25 x squared minus 4y squared. And why is that important? Because 25 and 4 are both perfect squares, which is what we want. Okay. So let's just identify this. Still got the 3 there, and we'll still have minus between these. But 25 would split up into 5 and 5, x squared, x and x. So it's really just 5x squared. And then 4 would split up into 2, and the y into y, but it would have to square that as well. So that gives us this form, a squared minus b squared, which allows us then to split this up into subtraction and addition of a and b. A is 5x, b is 2y, done. So if you do hate this, again, it's just meant to show that you don't have to do it with the rule, okay? I'm going to do this by factoring by grouping. Well, how can you do that with 2 terms? Because there's 3 terms. You just don't see the third one, all right? Well, I'll identify that. But before we do that, we need to identify in this binomial that 5 can be factored out from 5 and 605. And that leaves us. And that's pretty nice. That's pretty nice. But if we were to factor this by grouping, the term that's missing from this is plus 0w. Because if I add 0 of anything to anything, I end up with the same thing. Right? Even if it's w squared minus 121. Well, what does this do for us? It allows us to factor by grouping. Okay? So this one, I'm looking specifically at the C term, right? Negative 121. And I need two factors of negative 121 to add up to, in this case, 0. And that would be 11 and negative 11. All right? So I'm going to split 0, and that sounds weird, but I'm going to split 0 up into 11 W's and negative 11 W's. The thing is, outside of this factoring by grouping, there's only the rule in order to factor this stuff. No, we're not done yet. Sorry.
Sorry, I always get, I'm sorry.
Yeah, no, you're good. So I'm going to factor by grouping. So I'm going to group these. I'll factor out a W. And then in this other one, I'm going to factor out a negative 11. And that's what we wanted, that W plus 11 right there. So I've got the 5 in front, and I'm going to factor out a W plus 11. And then in that last set of parentheses, I've got W minus 11, which is what we should expect from this if we had used the rule, right? W plus 11 and then W minus 11. So the nice thing, again, is just that there is a different way, in case you hate all of the other ways, all one of them.